Value treatment. Problem statement. Load the load_diabetes datasets internally from the sklearn and check for any missing value or outlier data in the data column. If any irregularities found, treat them accordingly. This can be achieved by analyzing the outliers and the missing values and treating them accordingly. Let's start with loading the dataset that comes inbuilt with the sklearn library. We will now set a dataset to the loaded data. There is a lot more information there within the dataset. Let us extract the data and target independently out of it. This gives you an array consisting of the data and gives you the target or label for training data. You are supposed to determine for another set of training data by training your model with respect to this target data. Let us move a step ahead and extract the column names out of the dataset. It will be more convenient now to convert the dataset into Pandas data frame for further operations. This data frame ideally should include the column names, the training data, and the target data from the data set. Let's import the necessary libraries first. Name the data frame as df, and we will use np.c_ here to horizontally concentrate data and target values. Let's see how our resulting data frame looks like. It is important now to check if we have any missing data or null values. We will run the data frame method isNull combined with method any to do so. Since all the columns show false, we did not have any missing data as it shows false against each column. This is great. Now let's look at outliers. We will put the visualization library commonly called as matplotlib. We will use it to obtain a box plot for each of the columns. The box plot for age variable is spread mostly between 0.02 and -0.02. Similarly, sex is between -0.04 and 0.04. However, if you look at the box plot for the BMI variable, apart from most of the data lying between 0.03 and -0.03, there are a few data points lying above 0.13. These data points are kind of isolated from all the other data points. Hence, these must be removed for successful modeling. We can detect the outliers for the remaining variables in the same way. Now, these outlier values can be treated accordingly with different outlier treatment techniques. Great, now we know how to deal with missing values and outlier data. Let's quickly recap the steps we have covered so far. Import libraries and the data set. Convert the data set into data frame, check for missing values, check for outlier values. Manipulation. So what is data manipulation? Data manipulation involves performing some operations on data in order to gather some specific information from the data. Objects are Python's abstraction for data. So in order to manipulate the data, you can manipulate the objects, which in turn manipulate the data. Let's look at the functionality of the data object in Python. A data object is a two-dimensional data structure. That is, data is aligned in a tabular fashion in rows and columns. Different data objects are head, tail, values, group by, concatenation, merging. Let's understand each of these in detail. Functionalities of data object in Python, Part A. You can use the head function when you want to extract the first n rows of the data structure. N is the number specified as an argument to head function. Look at the given example. Here the values from 1 to 51 have been assigned to the data frame, and head starts count from index 0. So the output is from 1 to 6, and index starts from 0 and ends at 5. Since all the values are integer values, the data type is int64, where 64 is the bit size. Similar to head function, tail function returns the last n rows of the data structure. N is the number specified as an argument to tail function. Look at the given example. Here the values from 1 to 50 have been assigned to the data frame, and head starts count from index 0. So the output is from 45 to 50, and index starts from 44 and ends at 49. Let's look at the given example and try to understand the use of values function. Values function is used to return the series of the array that has all the values stored in a data structure. In the given example, you can see the values from 1 to 51 have been stored in data frame, and values function is called to output those values. Moving on, let's see what group by function is. Group by function is used to group the data frame according to a given condition. Here in the given example, you can see the data frame is grouped according to the team and ICC rank column. Functionalities of data object in Python Part B. In some cases, you may want to combine two or more data structures. Use the concatenation function in such cases. As you can see in the given example, there are different types of data stored within different data structures. Two data frames have been called, and later the concatenation function is used to combine the two data frames. Axis is shown as 1, which denotes that the two data sets have been combined using columns. Look at the following output. Here, all the columns have been combined from the two data frames. There is no relationship within the column or data set. Merging is similar to concatenation, but to use merge, you need to have a common column between two or more data sets or tables in a database. As in the given example, for both the data frames df1 and df2, one common column is team column, so it denotes that you can merge the two data frames based on the common column. There is a difference between concatenation and merging. Merging is the operation performed over objects using database joins, whereas concatenation is used to combine two or more data frames without having a relationship between them. Look at the following output. Here, all the columns have been combined from the two data frames with having one common column as team.